Alright, you guys have heard of transformations before, right? I'm not wrong that you guys have heard of those?
Yeah.
Okay, hopefully. So a transformation, that's our word that goes here. A transformation. I'm going to try to write in cursive so that it doesn't mess up the board. Handwriting might be messy. A transformation of a geometric figure. Figure is another word for like a segment or a shape or something. It's going to change the position, size, or orientation of the figure. Position, size, or orientation. So that means it could change where it is in the coordinate plane. It's going to change how big or small it is. It's going to change whether it's facing to the left or facing to the right, that kind of thing. That's what transformations do. The pre-image, all of this is just a bunch of vocabulary. So the pre-image is your before picture, basically. It's before you did any transformations. It's called the pre-image. The pre should be pretty indicative that it's the before picture. And then the image is the after picture. It's what the result is after you've done the transformation. So if you look at this diagram over here, this darker shaded in shape is the pre-image. So if you guys want to label that, this is the pre-image. And we know it's the pre-image because we have normal letters here, J, K, and Q. The image, which is over here in the stripy one, the image is the after picture, and you can tell that it's the image because they're using these apostrophes. Right? These little apostrophes tell you that that's the after picture. All right? A special word we use to say that we go from the pre-image to the image is the word map. You can say that a transformation maps a figure, maps with an S, maps a figure onto its image and can be described using this arrow notation. We've seen this before in Unit 2, right? In Unit 2, this meant if then. So with words, it means if then. With shapes, it means map onto. So in this picture, I have triangle JKQ maps onto triangle J prime, K prime, and Q prime. The little apostrophe that we use is called a prime. So that word goes here. In math, the little apostrophe, when you stick it onto a letter or something, or a number even, it is represented as the word prime. So we call this point K prime, or J prime, or Q prime. And so that's how you can tell that that's the after picture, if you guys see the little apostrophe. Now, I hope I can remember how to spell this word. Isometry. Have you guys ever heard of isometry?
No.
I-S-O, and then metry. Isometry. This is a special type of transformation, and isometry is a transformation in which the pre-image and the image are the same. And what I mean by that is that it didn't change what the specific shape looks like. Right? It can be flipped on its side, but a triangle is still a triangle, right? So we're going to see which one of these transformations are going to be isometries and which aren't. So let's talk about the 4 different transformations. We have our translate. Do you guys remember translate? Mm-hmm. A simpler word for translate means to slide or shift. Right? A translation slides all points of a figure the same distance in the same direction. So you're going to be given a coordinate plane for everything. You're just going to take it and go shoot. You can go to the right, you can go to the left, you can go up, you can go down. You can go in 2 different directions at the same time. It really just depends on what they're telling you in the directions. There are a couple different ways that they can present a translation for you. The easiest one is you're just going to use words like go up 1 and left 2. All right, that's easy. You guys know how to do that. Another way of representing a translation is like this. They're going to have the point XY, which is your pre-image point, and then they're going to have this kind of thing here, which is called the image point. Now the pluses and the minuses are telling you what direction you're going in and how much. So I want you guys to look at this and tell me what you think this would be in words. So I go from XY, so X goes to X minus 2. What direction do you think I'm going in? For the X's. If I'm subtracting from X, I'm going left. I'm going to say it's asking me to go left 2, but then they're also going from Y to Y plus 3. Up 3. So if you guys see this weird kind of notation, you can just turn it into words and then proceed from there, right? So the subtracting from the x means to the left. What if it was plus 2 to the x? Right, so you're going to the right. So you should be able to figure that out based on the operations and which variable you're using. This looks very much like a point, right? Kind of looks like the point, -1, 0. But look very carefully. The things that are parentheses are really more pointed, right? These are called vectors, kind of. So instead of parentheses, this is not a point. This is telling you what direction to go in. So over here is the x component of a vector. They're telling you they want you to go a distance of -1. So that's left. So you go left 1. And then the vector component for y is a 0. So what do you think that means? It stays the same. You go up 0 or whatever. It means stay the same. All right. So then you just don't change y. Don't change y. So you don't have to change both variables. You could do one, both, neither. It really just depends on what the directions are pointing. All right. So you can see this notation or the vector notation. So be prepared for it. Yes. J?
Yeah, because it's 0.
Well, no, it just means that when you're doing the translation, instead of going left and then up, you only go left. You don't do the up or down. Because you're not changing. You are changing the x, you just don't change the y. That's all. Alright, everybody okay with translation?
Probably in the ice house.
Oh yeah. I was just about to ask that. If you translate something, does that change what the shape looks like?
No.
Yeah, so this one is nice on shape.
Yeah, it only changes where it is, not what it is.
Correct. Alright, reflection. A good way to think of reflection, a reflection flips. That's usually a good word. Kind of represent that. It flips points across from the pre-image so that they are at equal distances from the line of line of reflection.
Oh.
What do you think I was going to say?
Line of best fit.
Oh no.
Hate trying to look at that.
That's okay. The line of reflection. So whenever you guys are thinking about a reflection, you usually think of a mirror, right? So when you guys are
same size.
Sorry?
Right?
Yeah, it's going to stay the same size.
So it's going to be the size.
Okay, well, yes. I want to talk about it before we move on a little bit though. When you guys are looking at your reflection, right? You have your face and then the surface of the mirror, and then your reflection is like a depth perception into the mirror, right? So the mirror is halfway between your face reflection and your own face. So that's the same way the reflection works in math. When we're doing a reflection, it's either going to be over a vertical line, a horizontal line, or a diagonal line. And for the vertical and the horizontal, all you have to do is count how far you are from the mirror and repeat that on the other side. So it's quite easy when they're vertical or horizontal. When they start getting diagonal, it gets a little bit more tricky. There are 2 rules you guys have to memorize. We're going to have to start memorizing stuff now for our rules here. And yes, this is an isometry because the actual shape itself does not change. You're just reflecting it so that it's kind of on its side, but it hasn't actually changed the shape. All right, a rotation, what's another word? Turn. A rotation turns all points of a figure around a fixed point, which is called the center. Now, the center could be a lot of different places. You could really pick any point that you want to be the center, but it gets more complicated the more complex your center is. So for our purposes, we're just going to use the origin. You guys know what the origin is, right?
Yeah.
0, 0. So in this class, we're going to be rotating around the point 0, 0. The degree measure that they're asking you to rotate is called the magnitude. Is it I can't remember if it's magnet or magna.
Latin is pronounced mag.
Is it I? Aha. Magnitude. Do you guys remember when you learned this? Did you use the paper turning strategy?
Yes. Yeah.
You turn your paper. So there's only there's only 3 degrees that you guys are going to be asked to rotate: 90, 270, or 180. So you have to remember clockwise and counterclockwise, and we just use our paper. And I'm going to show you that on the next page. But that's the general idea. Would a rotation be an isometry or not? Yes, it is. It preserves the shape. Doesn't really change it that much, just where it lies on the coordinate plane. Dilation. It's going to do two different things. It's either going to enlarges or shrinks a shape or a figure. Okay, so it's either going to get bigger or it's going to get smaller. The pre-image and the image are going to be the same shape, but what changes?
Size.
Their size. Same shape, different sizes. Right? We determine the difference in shape based on the scale factor. It's kind of like the magnitude for our rotation, but it's called the scale factor for a dilation. You're basically going to multiply everything by that scale factor to either make it grow or shrink. We also use the center for our purposes. It's almost always just going to be the origin again. And then if you guys are already given two shapes and you're trying to figure out how big one was compared to the other, if you're trying to find the scale factor, you just divide the image by the pre-image. And it'll simplify to a fraction.
So the center of the origin and the scale factor.
Well, it could be a lot of different things. The directions will tell you what scale factor is. Or you can find it using this equation, which I'll show you a little bit later. Would this be an isometry?
No.
No, it would not. So if you guys have a triangle like this, right, and then you make it grow, would you be able to say that those two are equal? No. No, so one's bigger than the other. So the dilation is the only one that's not an isometry. We're going to be talking about composition of functions a little bit later. This is what's important for your guys' project. So I have a quick question before we get there. If I ask you to do multiple transformations, no more than two, so if I ask you to do two transformations, do you think it matters which one I do first? Would I get a different answer if I do the transformations like this or if I switch their order? Does it matter? Yes, it does. If I translate first and then reflect, I'm going to get a different answer than if I reflect and then translate. All right, so order definitely does matter. We're going to talk about that a little bit later. Before we get there, let's take a look at these examples right here. What transformation have I done? Dilation. This is a dilation. You're going to see how it changed size. So that's your dilation. What about this one? Now, before you answer, when you see a question like this, you need to know which one was the pre-image and which one was the image. So which one is the pre? The shaded in one on the left. And how do I know that? It doesn't have apostrophes, the prime. All right, this one does have a little apostrophe prime symbol, so I know this is the after picture. So what did I do to go from here to there? I reflected. Does everybody see that? The V used to be on the left side, and then I flipped it over, so now it's on the right side. So that's your reflection. Does everybody see that? Okay. This one's a little bit more of a brain teaser. All right, you have to think about this in your head. If I had to lift the hood of this car to change the oil, what transformation would I have to use in order to do that?
Rotation.
Okay, a lot of people think it's rotate to begin with, but that's not fair. It's a reflection. Let me show you why. So to lift the hood of a car, right? There's a hinge, right? The hinge is a line, correct? So you are lifting the hood, the edge of the hood is being reflected using that hinge as a reference for where you're reflecting it over. If you were to rotate the hood, you have to literally like pull it off and then twist it. Because when you rotate things, it has to be about a point, not a line. You have to like yank the hood off and then twist it around. Like this, Logan. I'm taking
But
this.
it's not on the opposite
It
side.
doesn't have to be on the opposite side.
Then it's not a reflection.
Yes, it is. The
When
line
you do a reflection, it's on the exact opposite side of the original thing.
You can keep going. You can keep going though. You're using a reflection movement to open the hood. Okay? So this one's going to be a reflection.
Slimy. All my logic.
Well, that word didn't work very well.
Yelling on your front brake.
Alright, go ahead and turn the page, please. These are directions on how to do transformations. Now the extra piece of paper that I gave you guys, the one that has like a graphic organizer with the pictures and stuff, That's another expression of these in kind of a simplified way, but the way that they represent rotation is a little bit more confusing. So we're going to use the paper turning method for the rotation. You can use that if you want to as a reference, if you prefer, but I'm giving you two resources that you can choose from. Translation's real easy, right? You just read the directions and you got left, right, up, down, pretty straightforward. For reflection, this is where it gets a little bit more complicated. So we have three different scenarios. Scenario number one, if your line of reflection that they're referring to is either an axis, so the y-axis or the x-axis, or it's a horizontal or vertical line, which will be represented by these equations, x equals or y equals. They're going to be straight up or straight down. For those kinds of lines of reflection, all you have to do is count how far the points are from the mirror or line of reflection, and then mimic that on the other side by however far they were from the mirror. You want to keep them level with the original point, but go the opposite direction for that distance. However, if your line of reflection is diagonal, we have two different types of diagonal lines. We have y equals x, which goes like this with a positive slope. And then we have y equals negative x, which goes like this with a negative slope. These are two rules you guys have to memorize. Okay? You're not going to see them very often, so it's going to be hard for you to remember because you're not going to see it a lot, but it's very possible it will show up on the SOL. So please make sure you're drilling yourself and reminding yourself. If you're reflecting across y equals x, if the x and the y are the same, can't you switch the two numbers if they're equal? If y is equal to x, then you can rewrite the point. So that's basically what you're going to do. So if I have the point 2, 1, and you're reflecting across this, that point would turn into 1, 2. You take the points and you switch them. Okay? If you're reflecting over this line where it's y equals negative x, you're going to do the switch, but you're also going to change their signs. So for example, if I started with 1, 2, and I reflect over y equals negative x, these two numbers are going to switch position and change sign. Both. So it's like the contrapositive. You mean contrapositive?
No, we did corresponding where you would like change the fractions into like.
You mean opposite reciprocals? Like something like that?
I don't know.
Okay, it's fine. This is kind of like the contrapositive before, and this one's like the converse. Switch the order or switch the order and negate. So you can think of that connection between Unit 2 and this unit. Alright, so just be careful with which line they're asking to reflect over. Rotation is simple. We're going to practice that. You guys have seen the paper turning method before. They're going to tell you how many degrees to go, right? 90 degrees would be one turn. Everybody right? 90 degrees, one turn. 180 is 2. 270 is 3. Correct? Do you guys know the difference between clockwise and counterclockwise?
Yeah.
I hope.
Yes. Yeah.
Clockwise, because you guys don't know how to read clock, but clockwise is going around like this, and counterclockwise is going the other direction. So make sure you guys understand that. So listen, I'm just going to go over the paper turning method real quick for those of you who don't remember. You're going to look at a piece of paper. They're going to give you a coordinate plane with a picture on it. They're going to tell you how far to go. So let's say they say 90 degrees clockwise. I'm going to go like this, right? Then I'm going to look at the exact same picture. Guys, listen. I'm going to look at the exact same picture as if that's how it's supposed to appear. And I'm going to write down what the points look like in this orientation. Then I'm going to switch it back to where it started and graph those points that I just wrote down. Right? So we'll practice that a little bit here, but that's essentially what you do. And then for dilate, real easy, just multiply all the points by the scale factor. So if I say I want the shape to be 2 times as big, I'm just going to multiply everything by 2. If I want it to be a third of the size, you're going to divide everything by 3. So you're cutting it down by a third. So pretty straightforward. The only one that's difficult to remember is the reflection. You have to remember how to follow the rules for the special cases. So let's go ahead and practice that here. My first example here is a reflection across the line x equals negative 1. So first you guys have to go back to Algebra 1. Algebra 1 here. What does the line x equals negative 1 look like? Is it vertical or horizontal? It crosses the x-axis. It is vertical because it crosses the x-axis at negative 1. So everybody draw that into your picture, please. Lines that start with x equals need to cross the x-axis, so they are vertical. It crosses at the value -1. So we have this line here. This is one of our vertical mirrors, so all I have to do is count. How far is A from our mirror? Go ahead and count. 5. Well, it's 5 away, so you're just going to repeat 5 on the other side. So starting from the mirror, you're going to count out 5. 1, 2, 3, 4, 5. That's A prime. It's 5 away this way, so you're going to repeat that on the other side. It's always in reference to the mirror. Don't count from the axis. Always use the mirror, whatever they tell you that is. How far is B from the mirror?
1.
Just 1. It's 1 to the left, so you're going to go 1 to the right. You're going to go the opposite direction. On the other side of the mirror, that's B prime. How far is C?
3.
It's 3 from the mirror. And that's to the right, so now you're going to go left 3. 1, 2, 3. C prime. And then you're going to connect the dots. You have a nice little triangle like that. Yes, they can overlap. Yes, they can share points. And yes, they could possibly not even touch at all. All 3 possibilities can happen. I know it's coming. Does everybody see how I did that one? Yep.
Yes.
Okay. This one right here is one of our special cases. So let's put a little star. The line y equals -x is diagonal. This is a diagonal line. You guys don't have to draw it, right? It's a diagonal line with a negative slope. Who remembers? We just talked about it a few minutes ago. Who remembers what the rule is when it's y equals -x? Switch and change signs. It's the contrapositive, essentially. So you guys need to find the original point, then you're going to switch the numbers and change the signs. So, A. Let's write down the points first. What's A?
-4, 3.
Okay, so A is -4, 3. I want you to physically write down our work so it's a little bit more neat. So if our point starts at -4, 3, what would the image be the after we do the reflection?
3, 4.
-3, +4. You guys got it half right. The 3 does need to switch positions with the -4, but it also needs to change sign. So the 3 becomes negative and goes to the front, and then the 4 switches positions and becomes positive. Right? So go ahead and graph that. 1, 2, 3, 1, 2, 3, 4. Okay, switches position and changes sign. Now let's take a look at B. I'm going to write that along the bottom. What is the value of B to start?
-2, -4.
Yeah, it's 4. If I've counted correctly, I'm fairly certain that B is at -2, -4. Yes?
Yeah.
Okay. So remember, we're reflecting over that same line. So if I want to find B prime, it should be +4, +2. They switch and change sign, just like your positive. 1, 2, 3, 4, 1, 2. Okay. All right. Now let's find C.
4, -1.
1, 2. I'm pretty sure it's 3.
3, -2.
3, -1.
It's not where C is, it's the actual triangle. That's what
Yeah. Go up to the edge of the triangle, the point. And then let's have hand raised. Who thinks they know what C prime would be? Show of hands. Thinks they know. Bunch of people think they know. Right? Yeah. What do you think? 1, -3. Yep. Switch positions and change your signs. So 1, -3 is right here. It's going to reflect the triangle. Okay, so one more time before we move on past reflection, because we're done practicing with reflection for now. If your mirror is vertical or horizontal, all you have to do is count. All right, just mimic the distance on the other side of the mirror. For the diagonal ones, you have those two rules you have to memorize. So please make sure you have those in mind. All right, now we're going to do the translation ones. All right, these are real simple. For this one, I want you to move your points left 2 and down 4, and it's as simple as counting. So if we start with A, you don't have to write down the work or anything. You just count. So I'm going to go left 2 and down 1, 2, 3, 4. There's A prime. You can do them at the same time. Left 2 and down 4, all in one move. Same thing for B. Left 2, down 1, 2, 3, 4. There's your B prime. 1, 2, 1, 2, 3, 4. Just like that. Easy peasy counting.
Will we get points off for not writing the right?
Yeah. Yes, you will. All right, what about this one? It doesn't have words. It has the notation I was showing you guys before.
Right 5.
Okay, it wants us to go right 5,
And Y stays the same.
and Y stays the same. So all they want me to do is take my shape and go right 5. So it's a good idea to turn it into words or a quick abbreviation so you know what you're doing. So I'm not changing Y at all. I'm just taking everything and going to the right. So 1, 2, 3, 4, 5 gives me my A prime. 1, 2, 3, 4, 5 is B prime. 1, 2, 3, 4, 5 C prime. Just like that. Alright, is everybody with me for the translate? Pretty straightforward, yes? Everybody agree? Alright, now let's take a look at rotate. So again, rotate has two different aspects to it. What direction are you going in and how much? So everybody's going to have their paper, right? This first one wants us to go 270 degrees clockwise. So we're going to take our paper, we're going to turn it 3 times. 1, 2, 3. We're going clockwise like this, okay? So now you want to hold your paper like this. Our example is going to be right here in the middle of your page. I want you to look at your paper as if this is the normal coordinate plane. Sorry, it's in the middle. I apologize. It's in the middle of your page. Pretend this is the original coordinate plane. Take a look at A. It's on its side. But what is A? Where is it right now? -6, 2, right? So as your paper is sideways, it's fine. Go ahead and jot down -6, 2. Somewhere on your paper. Don't turn it back. Just jot this down. I know my paper is right side up, but as your paper is sideways, go ahead and jot that down. So our A prime, right, is going to end up at that point. So that's our A prime. Now, where is B? It's on its side, but if you take a look, it should be at 2, 1. Does everybody understand how I'm reading the coordinate plane? Yes?
I'm
Everybody?
reading it while looking at it like this.
Yes, you are exactly. You're reading it like it's on its side. And then for C, 1, 2, 3, 4, 5, 6, 7. 0, 7. Right? Once you guys have your points jotted down, you have everything taken care of. Now you're going to put your paper back to the original. Back to the original. And you're just going to go back and forth so that you can read your points. You're going to go ahead and graph them as it looks right here. Right? So I'm going to go back to the -6, 2. 1, 2, 3, 4, 5, 6, 1, 2. This is where our A was when we had rotated it. Right? That's our A prime.
Yep.
Our B, when we had rotated it, was at 2, 1. So that's where our B prime would be. And then our C was at 1, 2, 3, 4, 5, 6, 7 right here. So that's how you rotate a shape. You physically do the rotation with your paper and see where it's supposed to be, and then you go ahead and graph that with your paper like this. Back to the original.
Wouldn't G be both ways?
No, because when we're looking at it, we're looking at it like this. It was 2. Alright, does everybody see how the paper turning method works?
Yes.
No?
Yes.
Alright, I'll come over and help you. I want everybody to go ahead and try this one then. Go ahead and try this one if you're okay with the paper turning method.
No. So where's that point right here?
I thought the origin means clockwise.
Where's the
Well, you can go clockwise or
It doesn't say either.
no.
negative?
70 is gonna be 90.
It doesn't matter.
This would just be.
No matter what. It's all
That's how we're
good.
Forget this, okay? Forget everything like normal, okay? We're not normal. Like this. This will be 1-1. This will be starting as quadrant 1, so quadrant 2. 1, 2, 3, 4. 1, 2, 3, 4 is a big right. 1, 2. So it'll be 1, 2. 1 going up. You're trying to read it like it's originally is. What you mean, boy? How you see it. This is right. Make it more complicated.
I think it's but so now we're looking at it like this. The A is at negative 6, 2. And this is the regular.
I heard you like 13 times.
This is negative, so negative 6, 2. This is 2.
Yeah.
We're pretending it's not on this side. We're pretending this is the normal coordinate plane. And then when you write all those points down, you go 6, sorry, negative 2, 2, 1, 0, 7. Then you go back to the normal here. So for this one,
I know how much work we did on math based on the computer. It's not like I could just swivel my head. Better not be. I didn't mean to do that.
I know I'm right.
and you have all the points.
I'm telling you.
Yeah, I got.
Or I'm wrong.
I got 2.6.
She's right. Look up there, boy.
Hopefully, as you guys are working, you were able to get these points, right? Logan brought up a good point. Listen, the directions don't say which direction to go in. So if you think about it, if you guys were to take your paper and go 180 degrees this way, would that be different than going 180 degrees this way? No, they end up being the same. So for 180 degrees, they're not going to tell you what direction to go in. You can go either direction that you want. You're basically just turning your paper upside down. Did everybody get these points for the prime? So you go ahead and graph those. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4.
Races.
Right? You should notice that they do share points. That's okay. Right? Remember, they can overlap. They could share points, or they could not be touching at all. It really just depends. And that's your rotation. Right? Because rotation tends to be the most tricky one, I have one more for you guys to do.
Yeah.
Go ahead and try this 90 degrees counterclockwise for me, please.
Yeah. Clockwise. Wait, that's turn it around. No, wait, no, that's fine. I did turn it. I turned it.
How many times do you turn it so it's done?
Just one turn is 90.
Oh, so on the math space we have to do the rotation because I'm not gonna break my neck trying
I
to do
understand.
that.
Logan, you have questions, you can raise your hand and ask it to me. Okay. I will address that when class is over because I full mention this, I promise. I will show you. I will show you how to do this. We'll have plenty of time afterwards for you to ask the questions, okay? Hold on. Maybe, really?
What's 2 to 1?
Sorry?
Silent scale factor of 2 to 1.
You're gonna multiply. You want one of them to be 2 times as big as the other.
That's correct. We don't have to worry about the numbers. Oh, this is a positive. Positive.
Alright? Did everybody get these points? Take a look at the board, please. Did everybody get those for your primes?
Yep.
Your image points? So negative 4. 1, 2, 3, 4. 1, 2, 3, 4, 6. 2, negative 2. And negative 2 positive. Did everybody get those? Right, please make sure you guys are turning in the correct direction or your numbers will be incorrect. Alright, scale factor. Scale factor is pretty straightforward. Alright, with scale factor you're just going to be multiplying by whatever, dilation, you're going to be multiplying by whatever the scale factor is. So this one wants the shape to have a scale factor of 1/2. That means that they want the second shape to be half as big as the original. So you're going to multiply everything by 1/2. We're just going to divide by 2. Right? So for instance, the point A is at 6, 4. Right? 1, 2, 3, 6, 4. So where would the new point end up? 3, 2. Sorry, negative 6. Sorry, negative 3, 2. That's what I thought. It was negative 6, 4. To dilate that by a factor of 1/2, you're just going to divide by 2. You're going to do that for each of the points. So we took care of A. B is the point negative 2, negative 2. Negative 1, negative 1. Negative 1, negative 1. And then C, hold on. Point C is 2, 2. So 1, 1. Divide everything by 2.
You look at the plans from that.
We're not flipping it. Does everybody see how I did that?
Yes.
I don't want to go too fast and then get behind. Is everybody with me? You just divide everything by 2?
Yeah.
Wait, hold on. What?
Divide the points.
Oh, I was looking at C.
Why?
No, because like, like the actual letter instead of the point.
Now you're looking for the point.
Oh.
Alright, now this one. This is presented a little bit differently. Take a look. This says dilate with a scale factor of 2 to 1. That's not a fraction, right? It's represented as a ratio. So that just means that they want one of the shapes to be 2 times as big as the other one, right? This number that they have, they want the resulting figure, the image to be 2 times as big as the pre-image. Right? The first number always represents the image, the second one always represents the pre-image. So how would I make, because remember on the front I said to find the scale factor you do 8 times divided by A. So this is going to be the pre-image. So I want this to be 2 times as big. How do I do that? Times everything by 2. So the point A is at negative 2, 4. So if I start at negative 2, 4, it would turn into negative 4, 8. So the the prime, 8 prime is going to be negative 4, 8. 2, 3, 4, 5, 6, 7, 8 right here. 2 times as big. Point B is at 0, negative 2 originally. I want my new point to be 2 times as big as that. So what would that be? 0, negative 4. Remember that 0 times anything is still 0. So we got negative 4 right here. And that C is at 4, 2. Which would become 8, 4. 2, 4, 6, 8, 1, 2, 4. Oh, wait, that's right. Wait, coming up. 2, 4, 6, yeah, that's right. Ta-da. So again, for dilate, just take a look at the numbers they give you, and you're going to multiply, either shrink the figure or enlarge. Yes. Just remember this number right here is the after. This number is the before. So whatever number they have first in the ratio, that's what they want the new picture to look like. So they want it to be 2 times as big.
And then the one is
The one represents the original, the before. Okay? Questions on any of those? Alright. We're going to take a quick look at composition. This is what you guys are going to see on your projects. Being able to do 2 transformations in 1 question. Now remember the orders. The order is very important. So you guys need to do the first thing that I say and then follow up with the second. Do not try to change the order. It's going to change your answer. And then after that, we're just going to do a couple more SOL type questions down here with the multiple choice. Alright, so I have 2 different transformations for you guys. 1 and 2. The first one I want you to do is translate using this rule. And then after I do that, I'm going to get a new triangle. Based on that new triangle, then I'm going to go ahead and dilate by a factor of 2. Do not try to do both of them at the same time. Please do one at a time. You're going to draw the first figure lightly with your pencil. And then from there, you're going to draw your final answer, the second one, a little bit darker with your pencil. So the middle step, draw really lightly with your pencil so it doesn't distract you too much. So the first thing I want you to do is take this triangle and move it using this translation. Which you need to turn into words first. What does it want me to do?
So
Right
5, down 2.
Okay, so we're going right 5,
down 2.
down 2. Very good idea to go ahead and write that down. Right 5 and down 2. Okay? So very lightly with your pencil. Don't draw too heavily with your pencil. We're going to take our points and we're going to show where they would end up after the first translation. So I'm going to go right 5, 1, 2, 3, 4, 5, and then down 2, 1, 2. I can't show light on the board. It just has this.
Neither.
So, no, I have a pen that has a uniform density, but you guys can be light with your pencil. All right, what is this point? What's A prime? Where did A go? Okay, let's go ahead and write that down. This is going to be very important for you guys. I'm sorry?
Looks all the same even if I try to do it lightly.
That's fine, then you can draw big then. Big and small. Big point, little point. Alright, so our A shifts to 0, -1. What about B? I'm going to go right 5, 1, 2, 3, 4, 5, and then down 2, like this. Where did that go?
2, 1.
2, 1. Yeah, it's very important you guys write down the points for me, especially for the project, so I'm going to be grading the points that you write down as well as what you graph. So get used to doing that. And then C, I'm going to do the same thing. Right 1, 2, 3, 4, 5, and down 2.
Now, would this be a prime though? Like, would you push A prime, B prime for this?
I actually don't want you to label the points into the graph area because I don't want to make it too complicated. You can if you want to, but it may confuse you a little bit. So that's why I have it up here. You're just going to write down the points. Okay?
So, but it's still, so when we...
That's why I'm doing them one at a time.
You do 2 primes.
Correct.
Yeah, I was just making sure.
Yep. And so C prime is at 2, -2. Right? So the reason why I'm writing the points up here is so you don't have to put them into the diagram and get too confused because you don't want to put too much information in here. So now what I want you guys to do lightly with your pencil is go ahead and connect these dots. Or if you're using small and then big, these should be small points. When you draw your triangle, your final answer can be big points. Okay?
Can we use a color in this one?
Yes.
Okay.
Yep. That's a good point too. You can use different colors for them. It might be helpful. So now, we've done the first transformation. Our second transformation that we're going to do, our dilation, is going to be based on this triangle, not the first one. I'm going to repeat that. Our second transformation we're about to do is based on this triangle, not the first one. That's very important to remember. This one doesn't matter anymore. We're replacing it with our green triangle that we just drew. So now we're going to dilate by a factor of 2. What does that mean? Multiply. Multiply. So you guys can actually do that up here before you can graph it. If my point is at 0, -1, and I multiply times 2, what would it be?
0.
0, -2. So a double prime means that it has two transformations. That's going to be right here. So you guys can draw heavy, or you can draw a bigger point. Or use different colors. Right, this bigger point right here is going to be part of my final answer. What about 2, 1? What happens when I dilate that by 2?
4, 2.
4, 2. Multiply times 2, and you get a new point. 4, 2. Just draw this point heavily, a little bit bigger, or with a different color. And then what about C double prime?
4, -4.
4, -4. Again, multiply everything by 2. So when you guys connect the dots to draw this triangle, that would be your final answer. Yes.
Do we still have the geometry as well?
The effects aren't really changing that much until
I remember last year I had so. That's in 2 of my classes now.
that's okay. It just means you won't have to do the algebra 2 on this course.
What?
It just means you won't have to do the algebra 2 as well if you pass the chapter.
Really?
As far as I understand, because a lot of people can do it. But I'm pretty sure that's what it means.
I'd much rather.
Wait, if we
All right. I don't want too confusing a conversation to go into right now. All right. Does everybody understand that first one?
Yes.
Okay. Let's move on to the next one. I'm going to be doing two transformations. I'm going to reflect first over the x-axis, and then reflect again over the line y equals -2. Stay with me, guys. All right. Where is the x-axis? So it's horizontal axis right here. All right, so that's what we're going to reflect over first. So again, when it's horizontal or vertical, all you guys do is count. All right? So take a look at A. How far is A from the mirror? It's 1 down. So to reflect it, you're just going to go 1 up. Stay level with A, but just go the other direction, the same amount. What is that point? We're going to write them as we go.
0, 1.
0, 1. So A prime is 0, 1. That's where our image goes. How far is B from the mirror?
2.
It's 2 above. So now I want to go 2 below the mirror. Right, same distance, but in the different direction. Where does that point end up?
2, -2.
2, -2. Okay. What about C? How far is C? It's 3 down, so now we're going to go 3 up. So that ends up at the point 1, 3. And then lightly draw this triangle. I'll get that in a second. Alright, so lightly draw that triangle. And now this is what we're going to be using as our reference for the next reflection. Alright, so everybody see how we got that? Alright, our next reflection is going to be over the line y equals -2. What would that look like?
The up and down line.
It's a vertical line. It needs to cross the y-axis. It's going to be horizontal. If it's going to slice through the y-axis, it has to be horizontal. And it's going to be at, I'm going to squiggle this one to show it's the second line. This is the line y equals -2, if you want to go ahead and label that. You guys got to know your algebra. If you don't know how to graph these lines, you're not going to be able to do it. Okay? So the line y equals -2 is horizontal, crossing the y-axis at that value of -2. Okay, so again, forget the black, the original printed triangle. We're working off of our new one that we just made. Okay? This is our A prime, which is right here, our 0, 1. We're going to use our written reference here. How far is that point from the squiggle mirror?
3.
It's 3. Right, see how this point is 3 away from our new mirror? If it's 3 above, where would the reflective point be? 3 down. So 1, 2, 3. It's going to be right here.
Would it be -5?
0, -5.
0, -5. 0, -5. See, that's why it's important to write your points as you're going, so you know which one's which. Okay? So the double prime goes to 0, -5. Our B is at the 2, -2, which is right here. How far is that from the mirror?
4.
It's on top of it,
So it stays the same.
so it stays the same. So whenever your point is on the mirror, It's actually touching the mirror that you're trying to reflect over. That point does not change. So this one right here stays the same. Because it hasn't gone anywhere away from the mirror, so it just stays where it is. Alright, C is the point 1, 3 right here, C prime. That's 1, 2, 3, yep, it's 5 above. So I want to go 5 below. 1, 2, 3, 4. It's slightly off the graph. I apologize. Should make the graph a little bit bigger. So it's just 1 notch underneath. So if you count 5, you have to go 1 below. What would that point be?
1 negative
7. Plus 2.
2 negative 7.
2. Sorry, did I? Nope, sorry, I counted wrong. I accidentally grabbed my board shifted. I apologize. Technology. My board shifted and moved the point from where it's supposed to be. That's my bad. So that point. My board is not cooperating. I apologize. So yeah, that should be at 1, negative 7. Sorry for the way that the points lined up. Didn't work out too well. Once you guys connect the dots, that would be your final answer. That guy right there underneath. If you'd like to, another way that students like to show that's their final answer is by shading it in. So if you would like to take the triangle that's your final answer and shade it in, that's another way to show me that that is your final answer. Alright, how are we doing on that? Alright, I want you guys to try the next one on your own. You're going to be expected to do that for the project. So please do the 90 degrees clockwise and write down your points.
Oh, there's another one.
And then take that one and reflect over the y-axis. Go ahead and do it on your own, please, independently. We're almost done. You're not supposed to write the A prime after the right hand. This is A, B, and C. Find A prime, B, and C prime have actually. So from your perspective, right, you're going to use clockwise. That would be this way. So we're there. Clockwise, we're going this way. So go ahead and try it again. This should be, at that reference, it should be 0, 4, right? So it should be. Let's finish until here.
My access is on the line on the left.
Access both ways. Hopefully before you guys get too far, you should have at least those points for the first transformation. Yes?
Yep.
Hopefully. Okay. hopefully, you guys both points for the second question. So your final answer.
I got -2 and
Then you didn't do it right.
Your final answer should look like that. The secondary triangle should be over here.
Ooh, I always got the exact.
Right? So this is the kind of thing there on your project. There are going to be some questions where it's just one transformation, simple, easy, done. And then there are several that involve two. But you're only going to be putting the final answer on the project. So you guys need to be able to use graph paper. And I think somebody mentioned this like on MathSpace, so I want to make sure I bring this up. When you guys are doing the homework on MathSpace, if it's a rotation question, you guys can go ahead and use graph paper, or you can create your own little grid by hand. And if you want to use the paper turning method, that's how you would have to do it. So if you see a rotation question on MathSpace, because it's electronic, if you don't want to like move your phone, if you're not using your phone, you can use some graph paper to transcribe it down on paper and use it that way. All right? Now, before we move on, just a couple more questions that you guys might see on the SML, so you guys are used to that. This first question right here says, which of these represents a dilation with a scale factor of 3 to 4? Okay? None of these pictures have exactly 3 and 4. So how do you think you would approach this? Don't make your own.
There is no way we are doomed.
There is a way, I promise. Do you guys remember learning about ratios? When they gave you ratios, they said it has to be in simplest form. A ratio has to be in simplest form. Well, we're going to see what these would be in simplest form and try to get them to match. Okay. We're going to try to get them to match, right? How would I write this as a ratio? Everybody stay with me, please. 6 to 12. But is that simplified? You can simplify this 1 to 2 because they're both divisible by 6. So this simplifies, Carlos. I can tell you're using your phone. I know we're being a little bit more informal this class, but I still don't want you using your phone. So 6 to 12 simplifies to 1 to 2. Is that a 3 to 4 relationship? No. All right. Let's take a look. I'm going to go this way. What about this one? 6 to 16. What would that simplify to? 3 to 8. Is that 3 to 4? Can I simplify it any more to make it that way? No. What about this one? 9 to 12, which would simplify 3 to 4. Is that the one I want? Yes, it is. So you have to make sure ratio is in simplest form. Just simplify it down. All right. Take a look. How do I go from the one t to the other t? What transformation do I use?
Translation.
I'm asking for 2. I'm asking for just 1. So think before we look at the answer choices, right? I see that there are 2 reflections and 2 rotations. Which ones are allowed? Can these be reflections? Is there anything I can reflect over to have it kind of twist like that? No. So we can already rule out A and B. You just have to figure out how much was it rotated. 180. 90 degrees would put it in this quadrant. 180 gets it into the quadrant across from it. Okay? Guys, stop talking, please. Does everybody understand how we logicked our way through that one? Okay. Now, this one is not multiple choice. This would be an example of a TEI question on the SLL. Remember we have those questions where you can like plot points by clicking or something? There are questions like that on the SLL too. So, if I gave you this picture right here, I'm going to ask you if ABCD, this shape right here, was translated so that D ended up right here, where would B end up?
Oh, this kind of cool.
How? How would I even approach this? How would I know how to get
How
it?
many points D goes from to the other D, and then use that same formula for us.
Kirby? Yep. We're trying to find the formula here for what happened. So it said translate, so I have to figure out what direction and how much. So what's our translation rule?
-5 or -5
Okay, so we went
Everyone negative
left.
5 if you went slope formula.
We went left 5, right? See how D, the point D went 1, 2, 3, 4, 5, and then what? Down 1. So I'm going to mimic that exact same formula for B. So 1, 2, 3, 4, 5, 1. So that's where B should go. What is that? Negative 3, 4. So that would be the answer. They would want you to either plot the point or type that in. That's the kind of question you might see on the SQL as well. Now this question right here is asking what transformation occurred. And you have to look very, very carefully at the points.
Rotation.
I know your instincts are going to be rotate. I know that's what your instincts say. It should make sense because you're taking it, you're turning it on its side, right? But look very carefully at the points. If I had just rotated it, shouldn't X end up there? Reflection. It's a reflection. You have to look at the points. Watch. I'll do it again. If you were to rotate this shape, all the points would stay in the same order as you're rotating, but the X shifts down here to a different position. So it didn't rotate, it flipped. Okay? So this is a reflection. You guys have to tell me, what did I reflect over? What did I reflect over? Oh, this one's going to be a little bit complicated. You will not
Why
see
is
this.
an x-axis at 1?
You guys will not see this very often. This is a little bit of like an honors kind of question, but I'm going to see if you guys can figure it out. This is not going to be a reflection over a horizontal or vertical line. It is going to be a diagonal line. What diagonal line though? Do you think you can graph it, maybe? You got it?
No, I cannot, or else.
Wait, would it be the slope? Wait, what do you mean?
See this line right here? There's a slope of 1, right? It crosses the axis right here, right? We'll always have a slope of 1. What's the equation of that line right there? Does anybody know? It's y equals. You got that part. Good job. Does it have a negative slope?
Y equals 1 minus 2.
Positive slope. There's a positive slope of 1, so it's just 1x. What's the y? Minus 2. So reflected over the line, y equals x minus 2. Again, that's a little bit beyond you guys that have just kind of thrown that in there for fun. But there you go. All right, so for the remainder of class, we have a while until the end of class. The homework on math base is not open yet. I could only open it like in a certain increment, so it'll open at 2:45, I think. Was the increment. But if you guys want to practice logging in to make sure you still understand the process of logging in, that would probably be a good thing to do right now. It's the same process whether you're on your phone or your computer. So if you want to go ahead and try practicing that again, just make sure you're used to it. And then those of you who have not finished the graded assignment, please do so. The graded assignment that's due today, I want you to go ahead and finish that, please. I will be passing out the new one in just a few minutes. I want you guys to do a couple questions on the new one as well. I'll save that for the last 10 minutes of class. All right, so give me 1 second. Give me 1 second, guys. Yes, I just have to finish the recording. 1 second.
Okay.